Hello everyone, and welcome to our session today. I'm excited to have you here. Today's presentation is titled Lists versus Tuples in Python, and we're going to explore two fundamental data structures in Python programming. We'll look at what makes lists and tuples different, why those differences matter, and how to use them effectively in your projects. So, let's get started and dive into the world of Python data types. Let's dive into the concept of order preservation. When we talk about collections like lists, maintaining the order of items is crucial. It means that the sequence in which we add elements is the same sequence in which we retrieve them. This is especially important when the order matters for our program's logic or output. Next, we have dynamic storage. This refers to the ability of certain data structures, like lists, to grow or shrink as needed during program execution. Unlike fixed-size arrays, dynamic storage allows us to add or remove items on the fly, making our programs much more flexible and adaptable. Now let's look at square brackets. In many programming languages, square brackets are used to define or access elements within a list. They're a simple yet powerful syntax that makes working with collections straightforward, whether you're creating a new list or retrieving specific items. Moving on to mutable collections. This means that collections like lists can be changed after their creation. You can add, remove, or modify items within a list, which gives us the ability to manipulate data dynamically during runtime. Finally, we arrive at the introduction to lists. Lists are a fundamental type of collection that embody all these features we've discussed: order preservation, dynamic storage, use of square brackets, and mutability. They form the backbone of many data handling tasks in programming, providing a versatile and intuitive way to organize and manipulate data. Now let's look at the fixed data storage structure, specifically focusing on tuples. Tuples have a fixed structure, which means once you create them, you can't add or remove elements. This is a key characteristic that sets them apart from other collections. You create a tuple using parentheses, like this, which makes it clear that the structure is fixed from the start. One important point to remember is that the order of elements in a tuple is preserved, so the sequence you put in is maintained. This makes tuples useful when the order matters. Also, tuples are immutable collections, meaning once they are created, their content cannot be changed. This immutability can be very useful for ensuring data integrity. Overall, understanding these core properties helps us see how tuples are a reliable, unchangeable way to store related pieces of information in a specific order. Let's talk about some key differences between lists and tuples. First, lists support variable length data, which means you can add or remove elements easily. This makes lists very flexible for many programming scenarios. They also allow element modification, so you can change items after creating the list. When it comes to syntax, you'll notice that lists use square brackets like this, while tuples use parentheses. This is an important visual cue to distinguish them. Performance-wise, tuples are generally faster and safer. Since they are immutable, they can be optimized by Python, leading to better performance and less risk of accidental changes. Lists, on the other hand, are changeable, which gives you more flexibility but requires careful handling. Overall, understanding these differences helps you choose the right data structure for your specific needs, whether you need a mutable list or an immutable tuple. Now let's talk about when lists are ideally suited. They are perfect for applications that require frequent updates, meaning you often need to add or remove elements as things change. Lists also support a variety of built-in methods, which makes managing your data much more straightforward and efficient. If you're dealing with scenarios where elements change often, such as adding new items or removing existing ones, a list is very useful. It's especially handy when you need a dynamic collection, something flexible that can grow or shrink as needed. For example, if your application involves frequently storing and removing elements, a list provides the necessary functionality to handle these operations smoothly. So, whenever you're building a system that needs to adapt quickly and efficiently to changing data, lists are usually the way to go. When considering when to use tuples, it's important to understand their key advantages. First, they are useful as dictionary keys because of their immutability, which ensures the keys remain constant. This makes them ideal for storing constant values that shouldn't change throughout your program. In fact, when data integrity is a priority, tuples are the perfect choice because they prevent accidental modifications. Additionally, tuples offer better performance on large datasets, making them efficient for handling extensive collections of data. They're also great for fixed collections of items, where the set of data is known and won't need to change. So, in summary, if you need a collection of items that are constant, secure, and perform well with large volumes of data, tuples are definitely the way to go. They really align with the overall theme of writing efficient, reliable code. Now let's take a closer look at some examples of lists. First, we have nested lists like this one, 1, 2, 3, 4. This shows how lists can contain other lists, which is useful when dealing with complex data structures. Moving on, we have a simple list of numbers, 1, 2, 3, 4, 5. Lists like these are fundamental for storing sequences of values that we might want to process or analyze. Next, we see a mixed list, 1, Apple 3.14, which includes different data types. This highlights the flexibility of lists. They can hold various kinds of data, making them versatile for many applications. Lastly, we have a list of colors, red, green, blue. Such lists are common when working with categories or options in a program. Overall, these examples demonstrate the power and variety of lists, which are essential building blocks in programming and data management. All right, let's explore some interesting ways tuples can be used. First, tuples can be nested, meaning you can have tuples inside other tuples. For example, you might have a list like 1, 2, 3, 4, which contains 2 inner tuples. This is useful when you want to group related data together in a structured way. Next, we have the concept of coordinates, which are often stored as tuples. For instance, coordinates equals 10, 20, represent a point on a map or graph, with the first value for the x-axis and the second for the y-axis. Then there's the idea of single-item tuples. These are special because, to define a tuple with just one element, you need to include a comma, like single-item tuple equals 5. Without the comma, Python would interpret it as just a regular value in parentheses. Lastly, tuples are also great for storing collections of related items, like fruits. For example, fruits equals apple, banana, cherry gives us a simple, ordered list of fruit names. Overall, these examples highlight the flexibility of tuples, whether they're nested, used for coordinates, single items, or collections, making them a versatile tool in our programming toolkit. Now let's take a closer look at the advantages of lists. First, their flexible structure makes them incredibly versatile for various applications. You can easily add, remove, or change elements without much hassle. This adaptability is particularly useful when working with data that changes frequently. Next, the ease of modification is a huge plus. You can update your list quickly, which saves time and effort in your programming workflow. Then, we have the rich set of built-in methods that lists provide. These methods allow us to perform common operations like sorting, revering, or searching with simple commands, making our code more efficient and easier to manage. Finally, lists are especially suited for applications involving variable data. When the amount or type of data isn't fixed, lists give us the flexibility to handle that variability smoothly. Overall, these advantages make lists a powerful tool in your programming toolkit, helping you build more dynamic and adaptable applications. Now, let's talk about why tuples are useful. They are great for storing records or fixed data that doesn't change, which makes them ideal for situations where data integrity is important. One of the key advantages of tuples is that they require less memory overhead compared to lists, so they help us save space in our programs. Additionally, because tuples are immutable, they tend to be faster in operations, giving us a speed advantage, especially when working with large datasets or in performance-critical applications. And of course, their immutability ensures the safety of our data. Once a tuple is created, it can't be accidentally modified, which adds a layer of security and reliability. So overall, tuples offer a combination of efficiency, speed, and safety, making them a valuable tool in our programming toolkit when we need to handle fixed data reliably and efficiently. Both play essential roles in data organization, and understanding when to use each can really streamline your programming. Tuples are immutable, fixed, and highly efficient, making them perfect for data that doesn't change throughout your program. On the other hand, lists are mutable, dynamic, and flexible, allowing you to modify, add, or remove items as needed. When choosing between them, think about the specific needs of your program. If your data is constant, go with a tuple. If you need to modify it, a list is the way to go. This choice is a key part of working effectively with data structures, helping you optimize your code's performance and flexibility. All right, as we wrap up, it's really important to emphasize the value of practicing and strengthening your skills. The best way to become proficient is to choose the right structure for your exercises and projects. Remember, there's no one-size-fits-all. Sometimes experiment with examples to see what works best for you. That experimentation is key to understanding Python programming deeply. We've seen that lists and tuples are fundamental building blocks in Python, and mastering their differences and uses is crucial. Whether you're working with mutable lists or immutable tuples, knowing when and how to use each will make your code more efficient and reliable. So the main takeaway here is to keep practicing, experiment often, and choose the right structure for the task at hand. That's how you will truly strengthen your skills and become more confident in Python. Thanks for following along through this journey on lists and tuples. Keep coding and exploring.